So now that we've talked about the Java Executor interface and showed an example of how it could be applied and talked about some different ways to implement it, let's take a step back and discuss the pros and cons of this particular way of doing things. And we'll use our example application that computes whether random numbers are prime or not, just to make the discussion concrete. So the nice thing about the Java Executor interface is it allows us to transparently tune and replace the number and the type of threads within the prime checker app logic itself. So all the application logic that we saw here in Android, for example, that's completely independent of what kind of thread pool we use to implement the Executor interface. We could use the fixed size thread pool as we did here in the application example. We could use a cached or variable size thread pool, which we will do later. We could use a work stealing thread pool, which we'll also do later. And the rest of the app, other than the factory method that made this particular choice, doesn't know, doesn't care. So that's a nice way of decoupling things. However, not everything is rainbows and unicorns with Java Executor. It's a very simple interface. And in fact, to some extent, it's kind of a simple-minded interface. And therefore, it has some restrictions. So one of the tricky parts here is that it only allows concurrent processing of one-way runnables. And that requires us to tightly couple our prime runnable class with the main activity class from Android. Those things are joined together in ways that will be problematic if we need to do runtime configuration changes. Runtime configuration changes occur with Android when you take a phone that's in portrait mode and you rotate it to landscape mode or vice versa. And that causes the main activity to be destroyed and then a new activity to be created. And if we tightly couple the activity with the prime runnable, then chaos and insanity break out when the activity goes away. We also have another problem here. The IsPrime method is tightly coupled with prime runnable as well. So this is non-extensible. We only have one way to do it. The primality check is always applied, even if we've already computed previously the results for a given prime candidate. So later implementations will come along and decouple the computation to check if something's prime from other parts of the app. So we can either have a more efficient algorithm, or we can actually use some cool caching mechanisms in order to record or memo-wise the previous results of checking if a number is prime to avoid having to redo it again subsequently if we already know the result. Another huge problem with Java Executor is the lack of any lifecycle operations on the Executor interface. As you saw, there is one method and one method only: execute. So that means you can't shut down the Executor. You can't easily interrupt or cancel running tasks without doing some crazy things. You can't easily handle runtime reconfiguration changes gracefully. You have to restart your processing from the beginning. You can't take up where you left off easily without writing lots more weird logic into your code. So it doesn't handle change very well. And I guess that the bottom line here is that the implementation, or the interface rather, for the Executor and its implementation, of course, is just too simple for its own good. And as with many things in life, simplicity is a virtue up to the point where it's too simple, you can't get your work done. And we'll see lots of examples of that in other parts of Java and Java frameworks throughout the course. So that's the end of the discussion of pros and cons of the Executor. Even though it's not really the most powerful of the different mechanisms in the Java Executor framework, it's a good place to start because it gives you a simple example of doing things in a pool of threads without getting wrapped up in all the other mechanisms and methods we're going to talk about in subsequent discussions.